Imagine losing contact with a probe that has traveled billions of kilometers, venturing into the unknown regions of interstellar space. For almost half a year, cryptic messages filled with ones and zeros replaced the invaluable data from Voyager 1. Just when hope seemed lost, a stroke of genius brought this legendary probe back to life. Why did the probe send garbage data for almost half a year? And what brilliant solution repaired Voyager 1? In the early 1970s, NASA began an ambitious journey to explore the outer planets of our solar system. The vision was born out of a unique planetary alignment that occurs once every 176 years, allowing a spacecraft to use gravity aids to visit multiple planets during a single mission. This possibility led to the design of the Voyager program, which consists of two identical probes, Voyager 1 and Voyager 2, designed to exploit this rare trend. The main mission of the Voyager spacecraft was to make close-up studies of Jupiter and Saturn, their moons, and their rings. The purpose of the mission was to take detailed images, collect data on magnetic fields, analyze the composition of the atmosphere, and collect other scientific information that would greatly expand our understanding of these distant worlds. Voyager 1 was carefully designed to withstand the harsh conditions of space and operate independently far from Earth. The spacecraft was equipped with a series of scientific instruments, including imaging systems, spectrometers, magnetometers, and plasma detectors. These instruments are designed to provide comprehensive information about the physical and chemical properties of these celestial bodies. The spacecraft's communication system was an important component that allowed data to be sent back to Earth. This system included a high-gain antenna capable of transmitting and receiving signals over great distances. The vehicle's computer system was also state-of-the-art for its time, allowing the spacecraft to process data, execute commands, and adapt to unexpected conditions. On September 5, 1977, Voyager 1 launched from the Cape Canaveral spaceport in Florida on a Titan IE/Centauri rocket. The launch was successful and Voyager 1 began its journey through the solar system traveling at approximately 17 kilometers per second. Voyager 1's first major milestone was an encounter with Jupiter in March 1979. The spacecraft made a detailed study of the gas giant and captured stunning images of its swirling atmosphere, the Great Red Spot, and its many moons. The data revealed new insights into the planet's weather systems, magnetic field, and radiation belt. One of the most important discoveries was active volcanism on Jupiter's moon Io. Voyager 1 images showed massive volcanic eruptions, making Io the first known volcanically active body outside Earth. This discovery challenged existing theories about the geology of the moons and planets and opened new avenues of research. In November 1980, Voyager 1 reached Saturn, its next big target. The spacecraft provided unprecedented views of the planet's complex ring system, made up of countless particles ranging from tiny grains to large rocks. Images taken by Voyager 1 revealed the complex structure and dynamic behavior of the rings, including gaps and undulations caused by gravitational interactions with Saturn's moons. One of the main goals of the Saturn rendezvous was to study Titan, Saturn's largest moon. The instruments of Voyager 1 detected a dense atmosphere composed mainly of nitrogen with traces of methane and other hydrocarbons. The data indicate that Titan's atmosphere was similar to that of early Earth, raising interesting questions about the potential for prebiotic chemistry and the conditions for life. After completing its primary mission, Voyager 1 continued its journey to the outer reaches of the solar system. The spacecraft entered the Kuiper Belt, a region of icy bodies and remnants of the early solar system. Voyager 1's instruments provided valuable information about the composition and behavior of these distant objects, helping to understand the formation and evolution of the solar system.
In February 1990, at the request of astronomer Carl Sagan, Voyager 1 turned its cameras back to Earth to take one last image before shutting down the cameras for good to save energy. Known as the pale blue, this image showed Earth as a tiny, in the vastness of space, emphasizing the fragility and isolation of our planet. The heliopause is the boundary where the solar wind, a flow of charged particles emitted by the sun, collides with interstellar space, the thin gas and dust that fills interstellar space. In August 2012, Voyager 1 surpassed that mark, becoming the first man-made object to enter interstellar space. This historic achievement marked an important milestone in space exploration and opened a new chapter in the mission. As Voyager 1 reached further into interstellar space, it faced new challenges. The spacecraft's power supply, produced by radioisotope thermoelectric generators, RTG, gradually depleted, requiring careful management of the remaining energy. NASA engineers carefully designed shutdown procedures for non-essential systems to extend the life of the spacecraft. In the fall of 2023, Voyager 1 began sending incomprehensible data to Earth. The once reliable communication system was now sending cryptic messages full of ones and zeros that made no sense. Scientists and engineers at NASA's Jet Propulsion Laboratory, JPL, in Pasadena could not explain the anomaly. The data showed that the scientific equipment on board was still working, but the information received was unclear. Diagnosing the problem was particularly difficult due to the enormous distance between Voyager 1 and Earth. Radio signals took more than 22 hours one way, meaning it took almost 2 days to get a response for any diagnostic procedure. Engineers initially focused on the flight data subsystem, which was responsible for compressing and transmitting scientific data. They suspected that a particular chip in the subsystem might have malfunctioned. Despite extensive testing and many attempts to find the exact cause, solutions have remained elusive. Crew morale began to decline as the possibility of losing contact with Voyager 1 became more likely. Millions of fans around the world eagerly awaited updates from NASA, which continued to send progress reports and publicly share its frustrations. In early 2024, an exciting new approach emerged. Engineers recommended routing the error code to another part of the flight information subsystem. This risky operation required precise coordination and timing, as any mistake could result in permanent radio silence. On April 20, 2024, after months of effort and countless hours of dedication, the unthinkable happened. Voyager 1 continued to transmit coherent data. NASA's joy and jubilation was palpable when all 4 scientific instruments on board were fully operational again. This victory not only revived the mission, but also confirmed Voyager 1's legendary status in space exploration. Despite previous challenges in 2021 and 2022, this was the second successful sensor repair in over 45 years of service. After successfully resuming its mission in April 2024, Voyager 1 once again rose to the center of interstellar exploration. The spacecraft has already provided historical information about the outer planets and frontier regions of our solar system. It is now diving deeper into interstellar space and aims to study particle measurements, cosmic rays, and magnetic fields. This information helps scientists understand the structure and composition of space outside our solar system. Voyager 1's discoveries have already transformed our understanding, revealing unexpected particle densities and plasma flows. The probe may even reveal new objects or exotic substances that could change our view of space. Its golden records, destined for any intelligent civilization it may encounter, symbolize humanity's constant search for knowledge. Launched in 1977, Voyager 1's legacy spans generations, marking significant achievements in space exploration. Its interaction with Jupiter and Saturn offered unprecedented insights, and the iconic pale blue dot image captured imaginations around the world.
Silence. The probe was reactivated to study the boundaries of the heliosphere, which revealed a surprising transition in 2012. Now, its instruments continue to provide valuable information about interstellar space, helping to understand cosmic rays, magnetic fields, and particle interactions. Voyager 1's mission will likely last another 10 years until its batteries finally run out in the mid-2030s. Engineers continue to carefully manage the remaining power so that the spacecraft can transmit as much data as possible before its instruments finally go silent. The spacecraft's RTGs, which convert heat from the decay of radioactive materials into electricity, will eventually no longer produce enough power to operate science instruments and communications systems. As Voyager 1 continues its journey in interstellar space, it will focus on several key science objectives. These include the study of the interstellar magnetic field, the study of plasma waves, and the analysis of cosmic rays. By understanding the properties and behavior of the interstellar medium, scientists hope to gain insight into the larger dynamics of our galaxy and the processes that drive the formation and evolution of stars and planetary systems. Voyager 1 made significant contributions to our understanding of the solar system and beyond. Data collected by the spacecraft has led to many scientific discoveries, from the active volcano Io to a detailed analysis of Saturn's rings. The mission also provided valuable information about the heliosphere, the bubble-like region of space dominated by the solar wind, and how it interacts with the interstellar medium. Voyager 1's journey has inspired generations of scientists, engineers, and space enthusiasts. The mission captured the public imagination and highlighted the possibilities of space exploration and information service. In particular, the image of the pale blue has become a symbol of humanity's place in the universe, emphasizing the need for global cooperation and care for our planet. Voyager 1 remains at the forefront of interstellar exploration, providing historical data on exoplanets and the boundaries of the heliosphere. It is now diving deeper into interstellar space and aims to study particle measurements, cosmic rays, and magnetic fields. This information helps scientists understand the structure and composition of space outside our solar system. Voyager 1's discoveries have already transformed our understanding, revealing unexpected particle densities and plasma flows. The probe may even reveal new objects or exotic substances that could change our view of space. Its golden records, destined for any intelligent civilization it may encounter, symbolize humanity's constant search for knowledge. Voyager 1's journey is an example of human ingenuity and determination. Its mission has inspired new generations of scientists and engineers to explore the far reaches of the universe. As Voyager 1 continues its lonely journey, it will remain a beacon of human achievement that will expand our knowledge and challenge our imaginations for years to come.